Hi, I'm Rick Kaufman, Technical Marketing Engineer for the Technical Enablement Team here at Aruba Networks. This is the Aruba Restful Automation Series, and you are in episode 7. This is quite an accomplishment. Now, I'm just trying to show you how I know how to do this. It might not be the right way, but it gets things done, and it's the only way I know. Okay, so I'm sharing my knowledge with you, you seeker. Come on, join me for this episode, episode 7, where we're going to talk about the Python environments that we're going to develop our code in and how we want to kind of keep them separate. And then we're going to talk about Docker and Docker infrastructure briefly. It's not going to be a huge deep dive into Docker, but I just want you to know it's all about application portability. If you write an application and you want to give it to somebody, you want it to be easy for them to get it running and be able to use it, right? That's what really makes it great to share our applications is we have a vehicle in which we can put all the stuff that our application needs inside one single thing and share it with the world. That's what we want to do. We share as developers. So let's dive into the lecture and thank you for joining. Python virtual environments and Docker. These are tools that are going to help us develop our applications and deliver our applications. This is all about application portability, episode 7 of the Aruba Restful Automation series. And we need to figure out what's going on with the environment. On our workstation, we're going to write some code. Now, if I just go to my command prompt and say, oh, pip install Flask, whatever, and it just downloads any version of Flask. So it's downloading 2.2.2 here. And I develop my application in that. Well, I may want to go back and work on an older Flask application that had a different version of that Python library. So now I've got some conflict on my workstation, and that's just messy. And we want to keep things separate so we can work on applications from all different versions, right? So I could have, 5 different Flask applications and they all use a different version of Flask. So how do I keep that straight and organized? Well, we create these virtual environments. And it's really simple. We just say Python 3-m venv, and we give it a name. Then we say source, that name, bin activate, and now you can see the prompt changed. I'm inside that virtual environment. Now, anything I do inside that virtual environment isn't reflected outside of it. So I could do a deactivate, get out of this environment, and get into another one and do work in some other application. So this is just a way to keep things tidy. So this is like a very simple example, but you have your host. We'll create a virtual environment called Bob, and we'll pip install Flask 1.1.2, and then we'll build another virtual environment, Bob2, and we'll install Flask 109. Now you can see I'm working on 2 different versions of Flask with 2 different applications, but neither one of them know about the other. That's what virtual environments let us do. Now, containers are different. Containers were made so we could put everything our application depends on inside a Docker image. And once that image gets installed into a Docker container, it can run anywhere. So as long as somebody has another Docker engine, we can simply send them the text file of our application. And they can use Docker infrastructure to get that application up and running very easily. Now, if I'm looking at virtual machines, they're quite large. They have an entire operating system inside the virtual machines and all the things that make the applications run. Containers do not have an operating system. They basically think they own the operating system of the host. So we put our Docker image inside the container and everything our application needs inside the container, and I can pick that container up and give it to anybody. Well, I'm actually giving them the Docker image and they run it in their own container. So how do we pull that off? It's the Docker file. The Docker file tells Docker how to build the machine that is running our code. So we're using this and we're going out to Docker Hub out on the internet and pulling in this Python Docker image, and we're doing some additional libraries. We're adding additional libraries with @get, so we're running the apt-get, and then we're making some other directories with the run here below. We're making a directory to hold the application files, and we're specifying that's the working directory, and we're taking our code that we wrote and copying it in with the add dot dot, and we're doing the pip install to install all the Python requirements, and then we're exposing 5,000 inside the container to the outside world, and now we have this command that gets our application up and running. If we say Docker build and we point it at this Docker image, this Docker file, it'll come up and build the Docker image. So just a text file and Docker infrastructure, we can create Docker images and run them in containers. Really simple stuff. Now, if we want to get orchestrating it, where we have multiple images in multiple containers, we can use the Docker Compose. And you're going to see this inside your files. You'll see a Docker file and a Docker Compose. And that's what they're there for. Now, we're not going to go too deep into this, but just know that I can say I have a service called web here, and I'm saying build dot. So it looks for a Docker file in that directory and builds whatever is in that Docker file. And when it comes up, I can link that container to another container running a Mongo image. That's all that's going on here. It's straightforward. We're going to have this in our files, and we're going to just run these in Docker infrastructure. So to have Docker infrastructure on our desktop, we need to have Docker desktop installed, or you're on a Linux host just running Docker and Docker Compose straight up. Either way, that's the beauty of this. I have my application designed so it runs in Docker containers. So anywhere where there's Docker, my app will run. It'll run in Docker desktop. It'll run in Kubernetes in a very large data center. So it doesn't matter because we're using Docker, and that's why we're using Docker, okay? So it makes our app super portable, and people can use them and get them around. Now let's jump into the demo, and I'll just show you this really quick, and we'll just get on with this. Okay, let's build a Python virtual environment. So I'm going to say pip3, and I'm going to say list. So you can see all the Python libraries I have installed just in my base environment. So I want to work on a new application, but this time I want to use Python 3-m, and we're going to say VENV, and we're going to call this Bob55. Now we're just going to create this virtual environment. Now I showed you all the files I had installed in the base environment and all their versions. So if I say source here and I say Bob 55 / bin / active8, then my prompt changes to Bob 55. And if I do a pip3 list here, you'll see there are very few files here. So I can say pip3 install Flask, and I should get the latest version of Flask 2.2.2. Now we'll clear that, and you can see I'm inside Bob, and I want to do a pip3 list again, and you can see what just got installed by doing that install Flask. And you can see that I have Flask 2.2.2. Now, if I deactivate, right, I'm back to my base, and if I clear and I say pip3 list again, you can see that list looks incredibly different. And if we go up and take a quick look in the apps up here for Flask, you're going to see I'm running Flask 1.1.1 in the base. So using Python virtual environments, we can keep these Python libraries separate from each other, and we can work on different Flask applications that require different versions of Flask. That's as simple as that gets. Now, if we look in here, in our files of whatever application we're working on, if we have a Docker file, the Docker file is just a text file that says, go get Python off of GitHub, our Docker hub rather. This is a separate place where we keep Docker images. We go pull this off of the Docker hub, run a couple of things we want to install, and then copy some files over. I'm sending my work directory to my local directory op so I can develop my application, and I'm running the Flask application inside the container on port 5000. With Docker infrastructure to get all this up and running from the command line, I just simply type Docker compose, Docker dash compose up dash D to run it in the background, and it will go look at the Docker compose YAML, and it will say, oh, we're going to build a thing called my web, and I'm going to build it. So I'm going to look in the local directory for a Docker file and do whatever that Docker file says. Then I'm going to expose the port 5000 that the app's running to port 5004 on the outside and simply say, my volumes are here in opt. That's the directory I'm working in on my host. And I can develop my application from that. When I go to production, I would change this a little bit. We'll get into that later. But this is how we set up our development environment. Now, I'm running this on like 5004, but if you're not aware, you can always go into Docker Desktop and go to the dashboard, find your application like this one, Jinja X, and it will tell you I'm running on port 5004. It's also green, so it's up. And if I wanted to, with this Docker infrastructure, I could hover over this, click this icon, and I could actually get into the Docker container itself. Now you can see I'm inside this little Docker container running this little Flask application. Okay, so that's about everything you need to know about Python virtual environments and Docker containers. And we use Docker containers so our application can have portability, and anybody that has Docker desktop can take this exact same application and run it in a container on their desktop, or using Kubernetes as an orchestrator, deploy it in their entire data center. Okay, now we know that if we use Docker, that will make our applications super portable and we can share them with the world, well, anybody else that has Docker, and they can get our applications up running rapidly. That's awesome. So I want you to stay curious and on Google the error message as always. And I want you to join us in the next episode of the Aruba Restful Automation Series, where we're going to talk about PyMongo, and we're going to use Python to update, read, and write records to a Mongo database. Lots of fun. I want you to keep the dream alive. ArubaNetworks.com has this developer page and a dev hub page. Tons of great information. Get yourself an Aruba Central account because we're going to show you how to do some programming on Aruba Central. And then if you need further higher level learning and automation, I suggest any one of these websites below. You can find this information. So thank you for joining us for this episode, and we look forward to seeing you in the next episode.